Hey everyone, welcome back to another Edexcel IAL Maths past paper video. Today we're going to talk about Pure Maths 2 from the May-June 2024 series. So let's jump into the paper. Question number 1. Find the first four terms in the ascending powers of x of the binomial expansion of 1 minus 1 over 6x. Okay, so we know the binomial expansion, how this goes. So this goes from 0 to 9. First term goes, since we want in ascending powers, so this can go from 9 minus I, and this minus 1 over 6x could go power I. So the first four terms would be 1 minus 1 over 6x raised to power 9. I'm writing this approximation symbol or tilde to show that the first four terms is just an approximation of that. Or you can just simply write the first four terms also. So the first four terms will be 9c0, 1 raised to power 9, which is just remains 1. 1 over 6 part would remain 0. Then you have, 1 over 6 power would remain 0. 9c1 power 1 would remain 1, and minus 1 over 6x. Then we do 9c2 minus 1 over 6x squared plus 9c3 minus 1 over 6x cubed. So these are the first four terms. Now we just simply need to calculate them. So 9c0 is just 1. Plus 9c1 divided by 6, 3 by 2, and this is going to be negative. Then you have 9c2 divided by 36, this is just 1, x squared, and then this next one would be negative 9c3 divided by 6 cubed is 7 over 18. X cubed. Right. These are the first four terms. Hence find the coefficient of x cubed in the expansion of 10x plus 3 times by this. Okay. So remember, x cubed terms will come when 10x multiplies with the x squared term, and when the 3 multiplies with this particular term. So first you can find out the x cubed term. So 10x times by x squared plus 3 times by minus 7 over 18 x cubed. So this would become 10x cubed minus 21 over 18 x cubed. So this would become 10 minus 21 divided by 18, which is 53 over 6 x cubed. So this would become coefficient of x cubed is 53 over 6. Right, okay, so let's move on to the next question. Question number 2. In an arithmetic series, the sixth term is 2 and the sum of the first 10 terms is minus 80. For this series, find the value of the first term and the value of the common difference. Okay, so basically the sixth term, that means a plus 5d, that is 2, and sum of the first 10 terms, which can be written as 10 over 2, 2a plus 9d, this is equal to negative 80. Okay, so a and d are the unknowns, so we need to find them. Okay, let's simplify and rearrange this equation first. So 2a plus 9d minus 80 divided by 5, that is minus 16. So we have this equation. This equation can be multiplied by 2 to make into 2a plus 10d equals to 4. So this is our first equation, this is our second equation. So when you solve the equation simultaneously, this would become 2a plus 10d equals to 4, 2a plus 9d equals to negative 16. You subtract the two equations, change the signs, this becomes d equals to 20. Now we need to find out a, so a is therefore 2 minus 5d. So 2 minus 5 times by 20, 100, that is negative 90. So therefore a is negative 98, d is 20. Right. Hence find the smallest value of n for which sum of the first n terms is greater than 8,000. Okay. So we know the formula. This is n over 2. 2a plus n minus 1 d. Right, so we know a, we know d now. So this would be n over 2, 2 times by 98, which is 196, and plus 2 times by n minus 20 times by n, 20 n minus 20. Right? Okay. So you have minus 196 minus 20, which is minus minus 216. And since both of these are divisible by 2, we can just say 216 divided by 2, 108, and 10n. Right, so this would become 10n squared minus 108n. So this is, we need this to be greater than 8,000. So when you bring 8,000 on this side, this would become greater than 0. Right? Now, 108 is divisible by 2, but is 108 divisible by 4? It is divisible by 4, but okay, 10 is not. So 5n squared, 54, n minus 4,000 greater than 0. Right? Okay. Now we use the quadratic formula. 54 minus b, b squared, minus 4ac. So 4 times by 5 times by 4,000 whole under root divided by 2 times by 5, 10. So one answer would be 54 plus 54 squared plus 20 times by 4,000 divided by 10, 34.195, and the other one would be minus 23.395. So therefore, n for which as sum of first n terms goes beyond 8,000 is 35. Right? Okay. And that's the second question. Let's move on to the next question. Question number 3. Using the laws of logarithms, solve this equation. Okay? So it's a base 2 log. Right? So you can first take power over here. So this is 2 minus x. Oh, sorry, no. Log base 2, 2 minus x squared minus log base 2 x plus 10 equals to 4. This can be rewritten as 2 minus x whole squared divided by x plus 10 equals to 4. Now since this is base 2, we can do 2 minus x whole squared divided by 2 raised to power 4, which is 60. So 2 minus x whole squared, which is 4 minus 4x plus x squared, equals to 16x plus 160. Now we need to do we need to bring everything on one side, so x squared minus 20x and 4 minus 160, which is minus 156. So our next thing is to find out x, which is minus b plus minus b squared minus 4ac, so 4 times by 156. So 2 times by 1. So one answer would be 20 plus square root 400 plus 4 times by 156 divided by 2. One answer is 26. The other would be negative 6. Now we need to see which one of them is correct. So since in the equation it was 2 minus x and x plus 10, and we need to remember for log function x has to be greater than 0. So this means that for log 2 minus x, when you apply 26, this would become log 2 minus 26. Obviously this is undefined, but for we don't even need to check the other one, other x plus 10. For this one, log 2 minus x, so this becomes log 2 minus minus 6, which becomes correct. That means this is defined at that point. So x plus 10 also, 10 minus x minus 6 plus 10, this is also defined. So therefore the final answer we have to choose is negative 6. Right, okay. Find the value of log base root a to a raised to power 6, where a is a positive constant greater than 1. Okay, let's first write this. Log base root a to power 6. That's right? Okay. Now let's make this, let's change the base of this. So this would be log a raised to power 6 base a. So instead of root a, we change the base to just plain simple a, and this one would be log of root a. Okay. Now using the laws of logarithms, 6 can be multiplied and so can be half over here. So 6 log a divided by half log a. So although they can be cancelled, also there's one other factor that log a would be 1 also. So 6 divided by half is just 12. Right, okay, that's question number 3. Let's move on to the next question. Okay, so question number 4. F of x is equal to x minus 2, 2x minus 5x plus k, where k is a constant. State the remainder when f of x is divided by x minus 2. So basically they're asking, when you do f of 2, you're getting this entire term goes to 0 because of this, and you're left with 21. So Given that 2x minus 1 is a factor of f of x, show that k is equal to 11. So that means when you're doing f of 1 over 2. Now this is, just to write over here, x minus 2, 2x squared, plus 5x plus k plus 21. Okay, x minus 2. So this is 1 over 2 minus 2. 2 times by 1 over 4 plus 5 times by 1 over 2 plus k plus 21. So half minus 2, that is 0.5 minus 2, that is negative 3 over 2. This is 1 over 2 plus 5 over 2 plus k plus 21, and once again this is equal to 0. So we simplify this a bit further. This becomes minus 3 by 4. 3 times by 5, 15 over 4. And minus 3 by 2k plus 21 equal to 0. We multiply both sides by 4. We get minus 3 minus 15 minus 6k plus 84 equal to 0. So 6k is 84 minus 18, 66. So 6k is equal to 66. That means k is equal to 11. And that's what we had to show for the b part, right? Okay. Hence, fully factorize f of x. Okay, so to fully factorize, we need to do the long division. So we have so first we need to make it into a fully cubic equation. So this is 2x cubed plus 5x squared plus kx minus 4x squared and minus 10x minus 2k plus 21. And this is minus 2 times by 11, so this is minus 22. Right. So this simplifies to 2x cubed, 5 minus 4x squared, and this is k once again is 11. 11 minus 10 is just plus x and minus 1. Okay, so 2x cubed x squared x minus 1. Which one of them is negative once again? So that is, both of them are positive, and this one is negative. Okay, so we need to divide this by 2x minus 1. Right, so first factor would be just x squared. This one would become 2x cubed minus x squared. When you subtract, this one would cancel out. This one would become 2x squared plus x. So you multiply with another 2. X. So 2x squared minus x. This would become minus plus 2x minus 1, and then you multiply with x. 1. This one would cancel out. So full factorization is f of x is equal to 2x minus 1 and x squared plus x minus plus 1, and as you can see, there is no further factorization of this thing. Right, okay. Hence, find the number of real solutions of the equation f of x equal to 0, giving the reason for your answer. Okay. So since this part has no real solutions, you can find the b squared minus 4ac for this one, right? So this is 1 minus 4. This is negative 3 less than 0. So no real roots for x squared plus x plus 1. Therefore, only one real solution. The real solution exists for f of x. Right? Sorry, this was 1 and 2. Right, C1 and 2. Right, so this is 1 and this is 2. Alright, let's move on to the next question. Question number 5. Given that x and y are positive numbers such that x minus y cubed is greater than x cubed minus y cubed, prove that y is greater than x. Okay, so we can start by doing the expansion of x minus y cubed. So either you can use the binomial expansion over here, or you can do it this way, like x squared minus 2xy plus y squared. Either way, that is fine. The coefficients will be 1, 3, 3, 1 with alternate signs. So this one would expand to x cubed minus 2x squared y plus xy squared minus x squared y plus 2xy squared and minus y cubed. So as you can see, this becomes x cubed minus 3x squared y plus 3xy squared minus y cubed, as predicted, 1, 3, 3, 1 with alternate signs. Okay. Now, since this is the complete expansion for this thing, we need to show that x minus y cubed is, when it is greater than this, y would be greater than x. So when we examine this, this means that they're saying that x minus y cubed minus the sum of x cubed minus y cubed is greater than 0, right? So this means that they are saying, so if you do this over here, x minus y cubed minus x cubed minus y cubed, so you're left with minus 3x squared y plus 3xy squared. So they're saying basically that minus 3x squared y plus 3xy squared is greater than 0, right? So you divide this entire equation by 3xy, right? So you would get minus x plus y greater than 0, so this would become y greater than x. So this is your proof. Hence, when x and y are positive numbers such that x minus y cubed is greater than the difference of cubes of x and y, it is implied that y is greater than x. Right, okay. Using a counter example, show that the resultant part A is not true for all real numbers, right? So this means that you can use examples for any case. You can use different real numbers, that means negative numbers, different positive, 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 negative, negative, positive, negative, negative cases also. Right, so let's pick for example some test cases, some example cases. So positive, positive we have done. Let's say we want y greater than to be x. So let's choose this to be positive, this to be negative, this to be negative, this to be positive, and let's say both of them are, hey, wait a second, we need y greater than x, right? So obviously we cannot have greater than x case over here. So we can choose this one and let's say this one. So in this case, this is also -2 is also greater than 5. So this is y less than x, this is y greater than x, this is y greater than x. So now let's plug in the values in the x minus y cubed. So when you do the x minus y cubed, negative the sum of difference of the cubes, let's see what we are getting. So you have -2 minus 5 minus 7 cubed, right? So -2 minus 5, 7 cubed, minus the x cubed, which is -8, minus y cubed, which is 125. Okay, so in this case I think this might be greater, but let's see. So 7 cubed negative minus 8 minus 125, this is minus 210. So this is less than 0. So this is enough to show that this is the only one counter example is sufficient. But let's see this one also. Maybe this is different. So x minus y cubed, so minus 5 minus -2. So this is -3 cubed, minus 5 minus -2, right? X cubed minus 125 minus y cubed. This would become plus 8. So minus 27 minus 125 plus 8. This is greater than 0. So although this is fine, we only need one example. So when y is equal to 5, x is greater than -2, y is greater than 0, but x minus y cubed minus x cubed minus y cubed, either you can say this is less than 0, or you can say that this x minus y cubed is less than the x cubed minus y cubed. Therefore, it does not apply for all real numbers. Right, okay. Let's move on to the next question. Question number 6. Sketch the curve with equation y is equal to a raised to the power x plus 4, where a is a positive constant greater than 1. Okay. On your sketch, show the coordinates of the point of intersection of the curve with the y-axis, the equation of the asymptote of the curve. So exponential function goes this way. So for example, if this was a raised to the power x, the y-intercept would be 1, and the x-axis itself would be the asymptote. Right, okay. Since most of it is above, so 1, 2, 3, 4, 5, and so on. So if it is ax plus 4, we need for y is equal to 4 to be our Right. We will make it dotted diagram in a second. So this is our y equals to 4 horizontal asymptote. Okay. And our graph would actually go from crossing this one and there. Oh, no, sorry, no. This way. So somewhat, yeah. So let's make this better. Right. Okay. So this is your 5. This is y is equal to 4. This is your y-axis. This is your x-axis. Right. And yeah. Okay. So you can write the y coordinate as 0, 5 also. Either way, that's up to your taste. And the asymptote line, let's make it into a dotted form. So right. Okay. That's it. 0. Okay. Right. So that's our curve. Okay. The table shows the corresponding values of x and y for y equals to 2x minus 2x, with the values of y given in 4 decimal places as appropriate, using the trapezium rule with all the values of y in the given table. Obtain an estimate for integral of 2 to 3.5 2x minus 2x dx, giving it answer to 2 decimal places. Okay, so we can use the trapezium rule over here. So trapezium rule 2, 3.5, 2 raised to power x minus 2x dx. This would become h over 2. The first and the last value would come only once, but every other value comes twice. So h, the difference between the values is 0.3. So 0.3 over 2. First value is, wait a second, 0 and 4.3137. Then the other values are, wait a second, so let me write over here first. So 0.3 divided by 2, 0 plus 4.3137 plus 2 times y. Now we need to write the values and then I'll copy it into the answer space. So you have 0.3246 plus 0.8629 plus 1.6643 plus 2.7896. Right, okay. 0.3246 plus 0.8629 plus 1.6643 plus 2.7896. Right, so this becomes 2.339475, which can be rounded to 2.34 to 2 significant figures. 2 decimal places, sorry. Now, using your answer to part B, making your method clear, estimate 2 plus 2x. Right, okay. This is very straightforward. From 2 to 3.5, 2 raised to power x. If you have this and you add up 2x and you add up 4x dx, right? So this can become 3.5 2x minus plus 2x dx. So this would mean that you have 3.5 2x minus 2x dx plus from 3.5 4x dx. So this is 2.34, but this is 2x squared, because 4x squared over 2 is 2x squared, from 3.5, sorry, 5. So this one would become 2.34 plus 3.5 whole squared minus 2 squared, 33 over 2, 16.5. This is 2.34. This is 18.84. Okay. Next up is 2 raised to the power x plus 1 minus 4x. Oh, okay. So this is just simple multiplication by 2. So from 3.5 to x plus 1 minus 4x dx is just simply multiplied by 2 to 3.5, 2 raised to the power x minus 2x dx. So this is just 2 times by 2.34. 4.68. That's it. Right, okay. Now let's move on to the next question. Question number 7. The circle C1 has equation x squared y squared 8x minus 10y equals to 29. Find the coordinates of the center of C1 and the radius of C1. Okay, so both of those can be accomplished by completing the squares of this equation. So this would be x squared plus 8x plus 8 divided by 2, 4 squared minus 4 squared. And then you have y squared minus 10y plus 5 squared minus 5 squared equals to 29. So this one would become x plus 4 whole squared plus y minus 5 whole squared equals to 29 plus 16 plus 25. This 16, 70. So center is minus 4, 5, and radius would be square root of 70. Right, okay. In part B, you must show the detailed reasoning. The circle C2 has equation this. Prove that circle C1 and C2 neither touch nor intersect. So this is very easy. So if the two circles are not intersecting, the distance between their centers, let's call it D, is greater than the sum of the respective radii. So distance D between centers is greater than sum of radii of both circles if circles do not intersect. Do not intersect. Okay, so we need to find out distance between centers. So D is equal to, we have two centers, minus 4 comma 5. And this one was a 5 minus 8. Right? Okay. So the simple x squared, x minus x2. So minus 4 minus 5 whole squared plus minus 8 minus 5 whole squared. So this is 9 squared 81 plus 13, right? So 5 minus minus 8, or minus 4 minus 5, and this is 8 plus 5, 13, so 169. Now let's check the radii. So radius 1, radius 2 is square root 70 plus square root of 52. Right. 70 plus 52, 15.5. Wait a second. This is 15.577. What was the previous one? 169. 15.8. Right? So this is definitely greater. So D is greater than the sum of R1 plus R2. Hence, circles do not intersect. Right, okay. Let's move on to the next question. Question number 8. Solve for 0 to x to pi, 5 sine x tan x plus 13 equals to cos of x. Giving your answer in radians to 3 significant figures. Okay, wait a second. 5 sine x tan x plus 13 equals to cos of x. Okay, so we know that tan of x itself is sine of x over cos of x. So let's do that. So 5 sine of x times by sine of x cos of x plus 13 equals to cos of x. Right. So this becomes 5 sine squared x over cos of x plus 13 equals to cos of x. Now, one thing we can do is we can multiply both equations by cos of x. This would become 5 sine squared x plus 13 cos of x equals to cos squared of x. Now, sine squared can be broken down into, can be represented as 1 minus cos squared x. So this becomes 5 minus 5 cos squared x plus 13 cos of x minus cos squared x equal to 0. This becomes minus 6 cos squared x plus 13 cos of x plus 5 equal to 0, which can also be written as 6 cos squared x minus 13 cos of x minus 5 equal to 0. So let's see if we can figure out factors for this. So 6x squared minus 5 minus 13x. We have 5 and 1, but 3 and 2. So 3x, 5x. No. One of them has to be negative, okay? If we do 6 So let's try with a combination of 2 and 3. So if we do 2 and 3, you have 8, 15 and 2 right. So 15x and 2x. This one can be negative. So that means this is negative. Right, okay. So this is 2 cos of x minus 5 and 3x, 3 cos of x plus 1 is equal to 0. So, we get cos of x either 5 over 2, which is undefined at that point, or cos of x is minus 1 over 3. This is the only thing that can give us solutions. Now you can solve this with the help of the graph or with the cos diagram. So the cos diagram, remember the cos is negative in the second quadrant and in the third quadrant. So we need the values up till pi. That means in the second quadrant. Or using the graph up till this one. So cos inverse of 1 divided by 3 is, radians is 1.23, right? But this is pi minus that. 1.23. You can also do the minus 1 over 3, right? So you will get 1.9, right? So if you do the pi minus cos inverse of 1 divided by 3, you see we are getting the same thing. So 1.91, wait, how many decimal places? 2 decimal. 3 significant figures, so I think this is it. Right, okay. The temperature inside a greenhouse is monitored on one particular day. The temperature is H degrees Celsius inside the greenhouse. T hours after the midnight is modeled by the equation H is equal to 10 plus 12 sine kt plus 18, where k is a constant. Use the equation of the model to answer parts A to C. Right, okay. Given that the temperature inside the greenhouse was 20 degrees Celsius at 6 a.m., T hours after midnight. So that means T is equal to 6. And K is between 0 to 20. Find all the possible values of K for giving each answer to 2 decimal places. Okay, alright. So they gave us that, okay, H is equal to 10 plus 12 sine kt plus 18. So this is, okay, this was just simply part 2. Okay. At t is equal to 6, H was 20. So 20 is equal to 10 plus 12 sine kt plus 18. Now, just to make sure that we are looking in the same range, so we want k to be between 0 to 20, so 6k would be 6 times by 20, 120, and 6k plus 18 would be 138 and 18, right? 6k plus 18. Because k, the t is 6, right? Yeah. Actually, let's write over here 6k. Okay, so this means that the sine 6k plus 18 is 20 minus 10, which is 10 over 12, which is 5 over 6. One thing to remember over here, that this was in degrees, right? So we need this in degrees. So sine inverse of 5 divided by 6 is 56.443, and we can also try 180 minus that. 123, that is in the range. So 123.557. Okay, so this is your 6k plus 18. Now we need k, right? So this minus 18 and divided by 6. So we get 6.41. The other one is 180 minus that, 17.59 or 17.6. Right. Each answer to 2 decimal places. Okay, so a 59 would be fine. Right. Okay. Given that as k is between 0 and 10, find the maximum temperature inside the greenhouse. Maximum temperature in the greenhouse. Okay, so we have H is equal to 10 plus 12 sine KT plus 18, right? So maximum would be just 10 plus 12, but we want inside the greenhouse. Wait a second. Okay, so let's apply this onto the sine. So sine function. So you have k between 0 to 10. Okay, so t itself is between 0 to 24 hours. Okay. I think the answer, oh right, the answer is staring right out in our face. So maximum is basically just 10 plus 12, because maximum value of sine is from -1 to 1, right? Sine function of anything, so basically max would be just 22 degrees Celsius. Now find the time of the day at which this maximum temperature occurs. Give your answer to the nearest minute. So maximum temperature occurs when sine of kt plus 18 is equal to 1. So sine function becomes 1 at 90 degrees, right? So kt plus 18 is equal to 90 degrees. So right. So k value we can apply over here because they said k is between 0 to 10, right? So we can use the 6.41, right? So 6.41 t plus 18 is equal to 90. So t would be 90 minus 18 over 6.41. 90 minus 18 divided by 6.41. This is 11.232. which can be written as to the nearest minute. This is the hour, right? So we multiply by times by, wait a second, sorry, when you do this minus 11, this times by 60, you get 11 hours and let's say 14 minutes. So in time, this would represent 11:14 a.m. Okay, right? Okay. Because the time started from the midnight. Okay, right. Now let's move on to the next question. Question number 9. Figure 1 is a sketch of the curve C with equation this. The point P is a stationary point of C. Okay. Find using calculus the x coordinate of P, right? So we do the dy by dx. First, what we can do is we can multiply this inside. So 8x 3 by 2 minus 2x 5 over 2, because 3 by 2 plus x. So dy by dx would be 3 by 2 times by x 1 over 2 minus 5 over 2 times by 2 times by x 3 by 2. Okay. So 2 times by 4, so that is 12x 1 over 2 minus 5x 3 by 2. So we want to find out the c. So at c, dy by dx is 0, so therefore 12x 1 over 2 minus 5x 3 by 2 is 0. Okay. So what we can do to remedy the fractional powers is we multiply both sides with x of 3 by 2. Sorry, half would be fine also. Half would be fine also. So this would become 12x, so half plus half minus 5x squared equal to 0. Another way you could have done the same thing is by taking 12x 1 over 2 over here, and this is 5x 3 by 2. So when you do the square of both sides, you will get right. So 144x, and this one would become 25x cubed. So this way you will get the answer x 12 minus 5x equal to 0. So either x is equal to 0 or x is equal to 12 over 5. But if you go this way, we should be able to get the same answer. So you have 25x cubed minus 144x equal to 0. So x can be taken out. So 25x squared minus 144 equal to 0. So either x is equal to 0 or x squared is 144 over 25. So basically x is 12 over 5 plus minus. But they gave us some condition. X is greater than 0. So we will just use the positive one. Okay. Right. Okay. The region R1 shown shaded in the figure 1 is bounded by the curve and the x-axis. The region R2 also shaded is bounded by the curve x-axis and the line with equation x is equal to k. Right. Given that the area of R1 is equal to the area of R2, find using calculus the exact value of k. Right, so basically first we need to figure out, before we find out k, we need to find out the x coordinate of the x-intercept. So this is straight away just x is equal to 4. Right? This is simple deduction over here. So Okay. The y, this is part B, y equals to 8x 3 by 2 minus 2x 5 over 2. Okay. Now we said that the area of the sum of these two from 0 to 4, 8x 3 by 2 minus 2x 5 over 2 dx plus from 4 to k 8x 3 by 2 minus 2x 5 over 2 dx is 0. So either we can equate them, that means this area is the negative of this area, or a very simple thing, if we go from 0 to k, 8x 3 by 2 minus 2x 5 over 2 dx to be 0, I think we should be able to figure it out this way also. So let's see. Both ways would be fine. Right, so 8 times by, this is integration, 8x 5 over 2 divided by 5 times by 2 minus 2x 7 over 2 divided by 7 times by 2 from 0 to k is 0. So this would be 16 over 5x, so this time k, 5 over 2 minus 4 over 2x 5 over 2, right? 4 over 7 x as a k 7 over 2 equal to 0. So now when we equate them, just simply take them on the other side. K 5 over 2 equals to 4 over 7 k 7 over 2. This would mean that you have k 7 over 2 minus 5 over 2, which is just k. This would be 7 times by 16, 4 times by 5. Simple cross multiplication basically. Because you have k 7 over 2 minus 5 over 2 equals to just simple cross multiplication. So 3.5 minus 2.5 is just 1. So 7 times by 16 divided by 20 is 28 over 5. Right. And that's about it. Okay. Alright. Let's move on to the next question. Okay, so question number 10. The number of dormice and number of voles on an island are being monitored. Initially there are 2,000 dormice on the island. Okay. The model predicts that the number of dormice will increase by 3% each year, so that the number of dormice on the island at the end of each year form a geometric sequence. Find, according to the model, the number of dormice on the island 6 years after the monitoring began. Okay. So the first term in the geometric sequence will be the end of the first year, right? Not the 2000 itself. So it will be number of dormice 2000 times by 1.03, which basically represents 100% plus 3%, and number of years. N is number of dormice, and small n, or let's say t is time. Years after, right? Yeah, years. Number of years after monitoring began. Okay. So we need this 6 or 5 years. 6 years after that. Okay. So 2000 times by 1.03 raised to the power 6, which is 2388. So two significant figures, 3 significant figures, this would be 2390. Okay. Right. Okay. Now, the number of volts on an island is being monitored over the same period of time, given that 4 years after the monitoring began, this was 3690. 7 years after the monitoring began, this was 3470. Find the equation of the model of the form n is equal to ABT. Okay, so first let's write over here. So when t is equal to 4, n is equal to something, and when t is equal to 7, n is equal to 3690 and 3470, right? Just to make sure. Yes, okay. So this means that this would turn into, see, n is equal to ABT. So 3690 is equal to AB4. 3470 is equal to AB7. So now when you divide both sides, you get B cubed is equal to 34,7, 3690, like 0, 0 cancelled out, and AA also cancelled out, right? So basically what we're doing, 0, 0 cancelled, AA cancelled. So we need to take the cube root of 347 divided by 369. So you have 0.9, sorry, no. B is equal to 0.9797. So let's keep it as it is before we find out A. So A would be either one of these, 3690 divided by B raised to power 4. Okay, so this is saved. 3690 divided by answer raised to power 4, 4005. So we need to give them in two significant figures each. So this would be n is equal to ABT. This can be represented as n. 4000 times by 0.98 raised to power 2. Right, okay. When t is equal to capital T, the number of dormice on the island is equal to the number of the volts on the island. Find according to the models the value of t, giving your answer to one decimal place. Right, okay. This was 2000 times by 1.03 raised to power t equals to 4000 times by 0.98 raised to power 2. Okay, so you can solve this with simple indices also. You can do this with ln also, absolutely fine. So this is 1.03 divided by 0.98 raised to power t. 4000 divided by 2000 is just 2. So t ln 1.03 divided by 0.98 equals to ln 2. So t would be ln 2 divided by ln 1.03 minus ln 0.98. Okay, so you have ln 2 divided by ln 1.03 minus ln 0.98. So 13.929 in how many years do we want? One decimal place, so 13.9. Right. So that's the end of this paper. I hope you enjoyed solving this question paper with me. If you have any questions, doubts, or confusions, feel free to reach out in the comments below. If you would like some one-on-one coaching for the May June exam session, feel free to reach out with the links, with the WhatsApp number and the links given. Until the next video, take care. Bye-bye.